name is Ying.
Hi, my name is Fathi.
Well, hello there.
And my name is Muhaimin.
My name is Huam. Okay.
And my name is Muhaimin again.
The group from the 50
and 50
as in like 50% Chinese
and 50% Malay.
and 100% racist. Okay, today we will solve two questions regarding applications of derivative. So we'll start with question number one. So what is the area of the largest rectangular garden that a farmer can enclose with 500 meters of fencing if one side of the garden will be the side of the barn? So the question sounds very confusing, but actually it's not really. So we start with what information we can get from it lah. So the first is the area of a rectangular garden. So we know that it's going to be rectangular. Rectangular like this, right? That a farmer can enclose with 500 meters of fencing if one side of the garden will be the side of the barn. So meaning that one side of it is already taken up by the barn. So we do not need to care about one side of it. Let's just assume it's this side. It could be any side, but we just choose this side. So this is the barn. So that means 500 meters of the fencing is used to enclose from here to here. Right now, let's give this side a value. Let's say an unknown value, which is x. Which makes this side x as well. And which makes this side to be, since the total is 500, right? So 500, this side will be 500 minus
2x.
minus 2x. Like that. Okay? So now we have our equation. So now we will go back to what's area. So area of x, let's call this area of x, will be length times width. So what's your length? Your length is x times what's your width? 500 minus 2x. Which makes this 500 minus 2x squared. So it says here they want the largest area possible, which means we're looking for a maximum value. So right now what we'll do is we'll just find the derivative for area x, because that's how you get the maximum value. Next, I'll pass it on to my my teammate Fathi to continue explaining the question.
Okay. So we continue in what question. So the question is ask for the largest rectangular. So you need to find the maximum one. Okay. So how we want to find the maximum? We derive this equation. Okay. So we derive 500 for x. So next, after we derive it, we set this equation to equal to 0, because we want to find the x. So we equal to the 0, and then we get negative for x equal to 500, and x equal to 125. So okay, we get the x. Alright, sorry. Okay, when we got the x, we just substitute into the area equation. So we get x times 500 minus 2x. This means, sorry, Okay, x. Just substitute it. Okay. 1, 5. Then final answer is 3, 1, 2, 5, 0 meter square. Eh?
Yeah.
That's
Area.
area. So this is the final answer for this question 1. Okay, that's it.
Know that. Okay, so me and Huam will be answering question 2. So this is question 2, okay. The question is, given a 20 unit square of metal plate, find the greatest volume of the metal tray with no top, formed by cutting congruent squares from the metal plate. Okay, so this is a metal plate, and it is square. Okay, so the size of each of the metal plate is 20 centimeters. Okay,
Unit.
20 unit. Sorry. 20 unit. Okay, so this is 20 unit too, and it's a square, so all of it is 20 unit. Okay, so then what it wants is they want us to form a metal tray with no top by cutting the congruent squares from the corners of the metal plate. Yeah, from the corners. So from here to here, we do it like this. Okay. So these are the corners of the metal plate. So what we have to do is we need to cut each of this, and then from that we can fold up the sides and form the tray.
Okay, so can you imagine the tray? Very hard to imagine, right? Okay, for you to have a better understanding, I will show you this. We don't know the length of this, the square, so we just assume it as x. So all of this is x. And the length here, because it's 20 and minus 2x, because the length here is x, then x plus x is 2x, so it's 20 minus 2x. Same goes to here, 20 minus 2x. And now we have to fold it up to become a tray.
That's not how to. It's not like that.
Semangat.
So this is the tray. Imagine without this, without the square.
Let's just cut the corners. Okay.
Cut the
So it's easier. Okay. So I know the explanation before this was a little bit confusing. So we actually made a tray using paper. So this is what we did. We cut the corners of we cut each of the corners. Okay, so then we fold all the sides so that it looks like a tray. So this is what the question wants actually. Okay. So Huam will continue explaining about the calculations.
Okay, so now we have to find the volume of the metal tray. Volume is equal to the length times the width and the height. So the length is x and the width is 20 minus 2x times 20 minus 2x. So it's equal to 400 x minus 80 x squared plus 4x cubed. So this is the volume. Now we have to derive the volume. 400 minus 60x plus 12x squared. Because it's maximum. After this one,
Yeah. Yes.
by factorizing it. Okay, so now we
Finding the value of
factorize
x.
this equation.
To find the value of x.
4 and minus 3x, then minus So the x is equal to 10 over 3 and 10. So, okay, now we start to substitute the x into here. Stop. Here we are. Okay, so now we are out of space, so we have to move it here. Move, thank you. Okay, stop. So we'll sub the 10 over 3 into this VE. Hey, no, we should sub the 10 into this VE, the volume. So the Vx will be 10 times 20 minus, oh no, wait. We should use the equation. 400 times 10 minus 80 square plus 4 cube. But equal to 0. Why is it equal to 0? Because this is the 10 is the maximum, is the minimum value. So now we will sub the 10 over 3 into the equation. 10 over 3 into the equation. So after that we will get the volume of the metal tray. The answer. So now let's calculate the answer. 400 times 10 over 3 minus 80 10 over 3 squared plus 4 10 over 3 to the power of 3. So the answer will be 592 16 over 27 unit cube. And that's the volume for the metal tray. Thank you.
I'll admit I was wrong. What else can I say, girl? Can't you play my head and not my heart? I was drunk, I was gone. That don't make it right, but promise there were no feelings involved.